Hello everyone. I'd like to welcome you to this video titled Writing Equations from Tables, and you will need to get out your Go Math book and a pencil. I would like you to turn to page 345 in your Go Math book. Now the goal for this video is for you to understand how you can use an equation to show a relationship between two variables. So we're going to take a look first at writing an equation to represent a real-world relationship. So you can see on page 345, it says many real-world situations involve two variable quantities in which one quantity depends on the other. We talked about in yesterday's video that we have an independent variable and also a dependent variable. This type of relationship can be represented by a table, like we see right here. You can also use an equation to model the relationship. So here's the real-world situation. The table shows how much Amanda earns for walking one, two, or three dogs. Use a table to determine how much Amanda earns per dog, then write an equation that models a relationship between number of dogs walked and earnings. Use your equation to complete the table. So this kind of gets our feet wet with this topic. So you can see the number of dogs walked right here is 1 and the earnings is $8. The number of dogs walked for the second one, 2 dogs, is $16. 3 dogs, $24. Now, as we continue this relationship, it's important first of all to see how many dogs are walked. Okay, because we don't want to just keep adding 8 each time, because we go from 1, 2, 3, and also we see 5, 10, and then 20. And I don't know about you, but 20 dogs may be a little interesting to walk, but oh well. So we need to think through this table so we can fill in the correct answers. So it says for each column, compare the number of dogs walked and earnings. What is the pattern? Now it's important to understand that the pattern has to be the same throughout the whole entire table. So I could look at this and say, okay, one dog walked, we add 7 to that. That gives me $8. So 1 plus 7 equals 8. However, that would not work for my second one. 2 plus 7 equals 9. So that's not going to work. What else could I do to 1 in order to make it 8? I could multiply it by 8. 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24. And when you see a pattern like that that is consistent throughout the whole entire table, that is going to be the pattern. So we could say, and I want you to write this down in your book, each earnings amount is 8 times the corresponding number of dogs walked. That's just a fancy way of saying that number of dogs walked, the earnings is 8 times the amount of number of dogs walked. So understanding that, we can fill out this table. 5 times 8 would be $40. Hopefully they're not walking, man is not walking all these at one time. 10 times 8, $80. Not too bad for dog walking. 20 times 8, $160. I would like you to fill this in with me in your Go Math book so you can see the pattern there. Now let's keep moving down. So based on the pattern, Amanda earns $8 for each dog she walks. We see that. So it says write an equation that relates the number of dogs Amanda walks to the number she earns. And we're going to let E represent the earnings and D represent the dogs. So what this will be, we'll have E, the amount of earnings, will equal 8. Where am I getting 8 from? Every time she walks a dog, she gets $8. 8 times D. Now we can see, use your equation to complete the table for 5, 10, and 20 dogs. I kind of went ahead with that already. 40, 80, 60. Again, when you're completing these tables, make sure you look at that number up there. Okay, you don't want to just start, looking at the bottom there. You got to look at both numbers there. So it says Amanda's earnings depends on the number of dogs walked. We'll put that right in for letter E. So we could say that the number of dogs walked would be the independent variable. The earnings would be the dependent variable. In other words, as the number of dogs walked increases, the earnings increases. Okay, so the earnings would be dependent variable, dogs walked independent variable. So now let's turn over to page 346. And what it's saying here is writing an equation based on a table. So you can see there are 4 tables down here at the bottom. And basic idea at the top just says the relationship between two variables where one variable depends on the other can be represented in a table or by an equation. An equation expresses the dependent variable in terms of the independent variable. So we looked at this with that real world problem with Amanda walking the dogs. Now it's important to understand when there's no real world situation to consider, we usually say X is the independent variable and Y is the dependent variable. So the value of Y depends on the value of X. Okay, so whenever we're taking a look at this, we always want to write our equations. Let me just show you here. If I'm taking a look at this one, we're looking at Y equals whatever's happening to X. Okay, so you can see what happens to X in order to get it to 10. What happens to 12 to get it to 10, 11 to get it to 9, 10 to get it to 8. Okay, so we can see we're taking X, that amount, and we're subtracting 2 from it. Let's see if that works. 12 minus 2 is 10. 11 minus 2 is 9. 10 minus 2 would equal 8. So we have Y equals X minus 2. That would represent this pattern that we see in the table there. Let's take a look at number 3 together. So we have 10 going to 15. I'm sorry, going to 25. So first of all, we could say, okay, what are we doing to 10 to get to 25? Also, we want to start out with Y equals something's happening to X. So I could say add 15. So is it X plus Y equals X plus 15? Let's see if it works. 27 plus 15 does not give me 30 though. So I got to go back and check. Now if I multiply 10 times 2.5, I will get 25. 12 times 2.5 gives me 30. 14 times 2.5 gives me 35. So again, when you're establishing this equation, it has to be true for the whole entire table. So Y equals 2.5 times X. So 2.5X means we're multiplying the numbers in X by 2.5, and that will give us what is in the Y part of the table. Take a look at number 4. Again, we're going to understand that Y depends on what we're doing to X. Okay, we're not doing X equals Y. We're doing Y equals whatever's happening to X. So let's take a look at X. So we could say we're adding 5 to X to get it to 10. So 5 times 5 is 10. 5 times 4 is 9. 5 times 3 is 8. So that does work. What would not work is multiplying it by 2. 5 times 2 is 10. That may work for the first one, but remember, it has to be for the whole entire table here. So I have Y equals, and what's happening to X in order to get it to 10? X plus 5. So let's take a look at the next one here. So we have maybe a little bit of a tricky one. Remember, we always start out with Y. It's going to equal something. What's happening in X in order to get it to Y? Well, nothing is happening to X in the first section. So whenever we have something that's 0 and it spits out as 0, that's a good idea that we're dealing with multiplication, because remember, anytime you multiply 0 by a number, it's always 0. Okay, so that must mean it could be that we're using multiplication. Let's see. So what's happening to 1 in order to get it to 2? We can either add 1 to it, but that doesn't make sense, because if we added 1 to X, that means Y would be 1 over here. So multiply 1 by 2, that gives us 2. Multiply 2 by 2, and that's going to give us 4. So Y for this is going to equal 2 times X. Now let's take a look at 347. It's saying using tables and equations to solve problems. So it's saying you can use tables and equations to solve real world problems. So we looked at tables, we looked at equations, now we're going to combine both of them to solve these real world problems. So it says a certain 25% of the sale price of paintings at a gallery will be donated to charity. The donation will be $50 if a painting sells for $200. The donation will be $75 if a painting sells for $300. Find the amount of the donation if a painting sells for $1,200. So it's important to understand there are certain steps you want to take. You want to analyze the information. So think about the things that we know. Things that we know is we know that when the sale price of a painting is $200 and $300, those are some things that we know. And we also need to understand that we need to find the donation amount if a painting sells for $1,200. So some of the things that we know, we got to think about this information. It's hard, but we see a lot of numbers there, so we got to focus in on what we're trying to figure out. Okay, what we're trying to figure out, how much donation will happen if a painting sells for $1,200. Next, we want to formulate a plan. So we need to make a table that can help us out, to help us to determine the relationship between the sale price and the donation amount. So we've already looked at tables, and we can see how easy some of these problems can be to figure out. And then we can write an equation that models a relationship, and we can use the equation to find the unknown donation amount. So you can see they made a table for us right here in our Go Math book. As we move down page 347, we see the sale price $200, donation amount $50. Sale price $300, donation amount $75. So what you can see here is that 25% of sales, so if we multiply 200 by 25 hundredths, that's going to give us 50. If we multiply 300 by 25 hundredths, that's going to give me $75. So that helps us understand how we can find the donation amount of $1,200. What we do is we multiply, the formula could be D equals 25 hundredths times the price. Okay, so we take D equals 25 hundredths times the amount if it was 1,200, and we can see the donation amount is $300 there. All right, now, so understanding this, we kind of did this already, but just justifying and evaluating. So what we can do, we can substitute the values like we already did. 25 hundredths times 200 gave us that 50. 25 hundredths times 3 hundredths gave us a 75. And then 25 hundredths times 1,200 gave us that $300 there that would be donated when that is the price of $1,200. So let's take a look at a problem just like this, and we'll wrap up the video after this problem. It says, when Ryan is 10, his brother Kyle is 15. When Ryan is 16, Kyle will be 21. When Ryan is 21, Kyle will be 26. Write and solve an equation to find Kyle's age when Ryan is 52. So think about the information that we know. Think about what we know. We know when Ryan is 10, his brother's Kyle is 15. 16 and 21. So we can make a table. Think about Ryan's age. Okay, so we know that Ryan's age is 10, and then Kyle is 15. Ryan's age is 16. Kyle's age is 21. When Ryan is 21, Kyle will be 26. So we got to think of the equation that would go along with this. All right, so if I think about 10, I know that's increasing by 5 in order to get to 15. Okay, so with a problem like this, we know, and then 16 plus 5 is 21, 21 plus 5 is 26. Okay, so this is a real world situation, so we're not going to do y equals x. Okay, we're going to do Kyle's age equals Ryan's age plus 5. Okay, so that would be the equation that we could write to represent this situation. And that's going to help us figure out Kyle's age when Ryan is 52. So what we do is we just take Ryan's age, 52, add 5 to it, and that gives us 57 years old. That helps us answer that question. So this is another example of using a table and equation to solve a real world problem, just like we did on page 347. So this concludes the video on writing equations from tables. If you have any questions about this concept, please come and see me.